Okay, in question number 1, we see we have 3 interior angles. We know they all add to 180, so add them together for a total of 180. Combine the like terms, 65 and 85 equals 150. Subtract the 150, oops, equals 30. So x has to be 5. Number 2, so same thing, add them all together. And one of them is a 90, equals 180. Combine all the like terms. So we have 64, 154. And so we subtract, we get 26 rather. Number 3, so same thing. X equals 20. Number 4, here we got an exterior angle, so we use our exterior angle theorem, which says the measure of that exterior angle is equal to the sum of not the adjacent interior, but the other two, so 20 and 30, which is 50, so x has to be 25. Number 5, 55 and 55, we see these angles are congruent, so we can use the converse of the base angles theorem. Since those are congruent, the sides opposite them have to be congruent. So 3x and x plus 18 have to equal each other. So 2x equals 18, so x has to be 9. Number 6, it's an equilateral triangle, which means it's also equiangular. That's the corollary to the converse of the base angles theorem. Since they're all congruent to each other, they're all 60. That's what an equiangular triangle is, 60, 60, 60. So the 2x has to equal 60. So x then is 30. Number 7, use the triangle from number 1, classify it by its sides and by its angles. So by its sides, well, it doesn't give us the sides, but it looks like they're all different. Since the angles are all different, I'm confident that's true, so it would be scalene. Classify it by its angles now. Plug this in, that's 30, so we have a 65 and 85 and a 30. Those are all acute angles, so it's an acute triangle. Question number 8, use the triangle in number 3. Classify it by its sides and its angles. So 20, if we plug 20 there, we get a 60, 60, 60, which is equilateral, equiangular, and we learned that that also is equilateral. So it's both equilateral and equiangular. That's an extension now because of this last section. We didn't originally know that was true, but based on the last section we learned that. So we can now go ahead and use that. Okay, number 9, we're filling in this congruence statement. So Q had double arcs, so it's going to correspond to Y, so I need to start with Y. Then I went to R, which had a single arc, so it corresponds to X. And S had triple arcs, so that corresponds to Z. Now RS, I can just use this congruent statement, I don't even need to look at the triangles. RS, that's the second, third letter, so here second, third letter is XZ. Number 11, angle Z, that's the third letter, so it corresponds to S, so angle S. Now moving down here, this next section, state the congruence that's needed. So there's one missing. In order to use HL, what's missing? Well, I see they're both right triangles. That part's taken care of. And in a right triangle, the two sides that create the right angle, those are called legs. And so then the side opposite, that's your hypotenuse. So let's look at what congruences we have. We have this congruent to that, which is a leg. So we've got the L of the HL taken care of, but we don't have the hypotenuses yet. That's the part that's missing. So this hypotenuse, this segment AC, it's congruent to this, say, DF, that hypotenuse. So that's the congruency that's missing in order to be able to use HL. Number 13. They want us to use ASA. I've got an angle, I've got a second angle, but we need the S, and it's got to be the one between. And since it's between the A's, it's got to be the side between the angles. So we've got this angle, side in between it right here is that AC. And over here, between the two sides, we have side DF, or between the two angles, we have side DF. So that's the congruency that's missing on those. Okay, so number 14, 15. Is it possible to prove the triangles are congruent? Yes or no? That's the first question. If it is, we'll have to tell which one. If not, we're not. And as I look in 14, I see there is a shared side that's not marked congruent. So there is two sides with the angle in between. Two sides, angle in between. That's SAS, since the angle is in between. So yes, SAS. Number 15. There is a side that they share, so that's congruent as well. They do happen to be right triangles. If I had two sides and not include an angle, that's not one of these, but since it's a right triangle, their hypotenuses are congruent, and a leg is congruent, that's HL. So that is a yes, we can do it, and we can do it by HL. Alright, so now list three side or angle congruencies. So I'll start with the single dash. MX is marked as congruent to PX. It also shows the double one, QX, is congruent to NX. But then there must be a third one. Well, that's vertical angles. Vertical angles don't have to be marked congruent because you should just know they're congruent. So I need to state that. I can't call it angle X, too much going on there, so I can call it angle MXQ. And so I'm going to go, of course, my order. If I started with M to X, I went down a single dash side, so I should start the single dash side here. So PXN is the other angle. So there's my three angle congruencies. So a congruence postulate that I'm using, well, it's two sides with included angles, so that's SAS. And now I give the triangle congruent statement. So triangle, maybe I'll call it M, it doesn't matter what order, MXQ, MQX, QMX, whatever. I'll go MQX for fun. But name the other one in matching order. So if I started with M, that's on the end of the single dash side, so I'd have to start with P. Then I went to Q, which is on the end of the double dash side, so that corresponds to N. And X is a single arc in both pictures, so X is congruent to itself. And now we get into the proofs. MLK is congruent to NLK, that was given. MKL is congruent to NKL, that was also given. That's only two congruencies. That's an angle and that's an angle. We need something else. So look at the picture, and oh look, they're sharing a side. And so this is LK. It's congruent to itself by reflexive property. And it's a POC since it's congruence. So now I have two angles with a side in between, so we can say the triangles are congruent by ASA. And now as I move to the last proof, we had two givens, midpoint. Use the definition midpoint. If you look that up on the sheet, we see that a midpoint cuts a segment into two congruent parts. So since X is the midpoint of MP, it cuts it into two congruent parts. That's the single dash sides there. MX has to be congruent to the other half, which is PX. Oops. And then we had another statement that X is the midpoint of QN, so it's going to cut that one in half as well. So that should be our next line. That QX is congruent to NX. That would be definition of a midpoint as well. So now we've got two sides. Oh, look, we have vertical angles here. So I better say they're congruent to each other. So angle MXQ is congruent to triangle PXN. And that would be vertical angles theorem. So now we've got two sides are congruent and an angle, and it is the angle between it, angle, side, or sorry, side and then an angle, then a side. SAS is how I know that the triangles are congruent. And because they're congruent, now everything else, all the other corresponding pieces are congruent, including M being congruent to P, because those are corresponding parts on congruent triangles, therefore they're congruent. That's the CPC, TC. Corresponding parts of congruent triangles are congruent.